Okay, hello, and welcome to another HSC Geography video. Today we're going to be having a look at vertical exaggeration. Today we're going to be having a look at vertical exaggeration. So we've done that a number of times in class. Vertical exaggeration is very simple. It's simply dividing the horizontal scale of a cross-section by the vertical scale of the cross-section. And the best way to remember that, or the easiest way to remember that, is vertical exaggeration, VE, HS divided by VS. And you know which one goes first because H comes first in the alphabet and V obviously comes second, so put that second. Okay, so to figure this out today, we're going to be looking at this hand-drawn topographic map, or sort of. The two things that I want to draw your attention to before we start is clearly the contour interval for this map is 20 meters, so you know that every single contour line goes up by 20. Also, the scale of this map is 1 to 50,000, so 1 centimeter to 50,000 centimeters. So that is 1 centimeter on the map equals to half a kilometer in real life. The 2 points that we're plotting between is X and Y. So in order to be able to do a vertical exaggeration, we have to have a cross section. So I'm going to quickly plot that for us. You all remember how to do a cross section, I'm sure. But I'm very quickly going to line up evenly between the points X and Y. I'm going to mark every single contour line that we pass through. Pretty simple. I'm also going to mark X and I'm also going to mark Y, which is going to be useful in a minute. So the contour interval for this map is 20 meters. There is no contour line, there's no numbers marked onto any of the lines here. But we know as geographers that that just means that every single one of these must be going up by 20. So I'm going to quickly mark those on. I'm upside down from you. See if I can go down like this. 20, 40, 60, 80, 100. Now because this is the same line, I'm going to mark it again. We're now coming back down. 80, 80, 80, 60, 40, 20. Okay, so there we have it. That's our first step of making our contour line, making our cross section. So normal cross sections work by having a true profile. So the true profile is where the amount that we go up by along this axis is the same amount that we go along by on this axis. And it's the contour map that tells us, or the topographic map that tells us. So here the scale is 1 to 50,000 centimeters. So every centimeter along here will also be to 50,000 centimeters. So every centimeter along here we need to mark as up to 50,000 centimeters, or 50 kilometers. Or half a kilometer. So I'm going to go about marking that up here. So the first one will be 500, which is obviously half a kilometer. 1,000, 1,500, 2,000, 2,500. Just to clarify, because I'm keeping it within that scale of 1 to 50,000. I don't have to mark along the bottom here, it's just a given. Every centimeter this way will be 50,000 centimeters, or 500 meters, every centimeter this way. I'm not going to go right to the top because in this instance it's not going to be needed. So I take our cross section, which I marked earlier, and I line up my Y point at the start and my X point, which unfortunately will just slightly fall off this one here. Hope you can get a good look at that. And now it's a simple matter of marking my height. So here is where the issue arises, and this is where vertical exaggeration is so important. This is 20 meters above sea level, but our very first or smallest point we can go up to is 500. So clearly, if I'm going to mark that, I've got to mark that just above the line. 40, could have marked that just above the line. 60, just above the line. 80, so forth. I got up to 100. Yeah, I get a little bit higher at one point. I come back down, 60. So when I join all that together, just like that, this line is almost completely useless to us. It tells us very little about the actual shape. It's very difficult to analyze what's happening inside of this cross section. So this is why we use vertical exaggeration. Vertical exaggeration is where you change what's happening on the vertical axis. So instead of going up by the scale, which was recommended, which, and I'll remind you, I'm sure you remember, but was 1 to 50,000, we're going to get rid of that. I'll wait for that to focus. I'm sorry about my camera. And I'm going to move it up by a much more sensible figure. In fact, I'm going to move it up by 50 meters. 50, 100, 150. Even, I probably should have done this smaller, actually. We'll see how this works out. Okay. In fact, I'm almost certain I should have done this taller. But anyway, we'll see. So now it's much easier to mark on these heights. So 20, I can mark somewhere here. 40, just on there. 60, above. 80, just below that 100 mark. 80 again. 80 again. Now go right up to 100, 100, 80, 60, 40, and back to 20. Now let's join that up this time. That's a much more useful line for us to be using as opposed to this previous line here where the scale was not exaggerated. Here we've exaggerated this edge and we've got a much easier line to interpret what's happening between those 2 points. Okay, so you'll always be asked, what is the vertical exaggeration of this map? And that's simply just referring back to this equation. The vertical exaggeration will be whatever the horizontal scale is divided by the vertical scale. So in this instance, the horizontal scale, the horizon, this edge here, we know is that 50,000 mark. So that is 500 meters. That's half a kilometer, so I've just changed that from half a kilometer to meters, 500 meters. This axis here is going up in lots of 50. So it's 500 divided by 50, which is 10. So the VE for this map here is 10. We've exaggerated this axis by 10 times, and it's given us a much clearer line of what's happening in this particular cross-section.